So now that we have our p-values or know how to compute our p-values, we can make the decision for our hypothesis test. So to determine if your p-value is extreme enough to not be due to chance, we compare it to our predetermined probability. That's the alpha, the significance level of the test. The decision rule is this: if your p is less than the alpha, then we reject the null hypothesis. And if your p is greater than equal alpha, then we do not reject the null hypothesis. So note, if we do not reject H0, it does not prove that H0 is true. It just means that we'll assume it's true because the sample evidence doesn't show otherwise. So you can't prove that H0 is true. So when we do reject H0, when your p-value is less than alpha, we say that there is sufficient evidence to believe that HA, the alternative hypothesis, is true. When this happens, that's what we call a statistically significant result. So we say the results here are statistically significant. And then if we do not reject H0, we say that there is not sufficient evidence to believe the alternative is true. So both of our conclusions are always in relation to the alternative hypothesis. And then we say that the results are not statistically significant. So let's apply these statements to the context of the problem below. So 5 years ago, the graduation rate was 73%. Since then, the superintendent did changes. 342 out of 450 students graduated. We're testing the hypothesis that the graduation rate has increased here at the alpha 0.05 level. So decision of the test, or alpha is 0.05. And remember that the p-value for this test was 0.0764. So that's actually greater than 0.05, which is our alpha. So p is greater than alpha. That's this case, greater than equal alpha, do not reject. So our decision for the test is do not reject H0. And then our conclusion: if you do not reject, then there is not sufficient evidence. So there is not sufficient evidence to conclude that our alternative hypothesis is true. And our alternative, we were testing this one, remember, H0HA. For this one, we're testing to see if it increased. So this was p greater than the 0.73. That was our alternative. So there's not sufficient evidence to conclude that the proportion is greater than 0.73. So that's our conclusion. It's always related to HA. And then H0, remember, was less than equal 0.73. And then remember, for the two-tailed test, our p was 0.1528, I believe. So that one would also be do not reject and not sufficient evidence. So both of those, we would not reject the null hypothesis. We'd say that the result was not statistically significant.